All right, one more example. Let's compute the integral of 3 plus secant x tangent of x, all that in a bracket, times in a bracket 6x plus 2 secant of x, all that to the power 4 dx. All right, here, so obviously this is not a basic integral, so we're going to try to use a substitution. So I see two terms multiplying each other, but I see something inside of a power 4. Let's use the inside of that power for the substitution. So let's use 6x plus 2 secant of x as u. So u is going to be equal to 6x plus 2 secant x. Then right away, this is a computation, so secant of x. So you compute du over dx. So you're going to get 6 plus 2 derivative of secant is secant of x tangent of x. And then you isolate dx just by swapping it with the formula on the right. So you get the du over 6 plus 2 secant x tangent x is equal to dx. So we have a formula that we computed using a formula for dx that we compute ourselves by computing the derivative of du. And we know that the 6x plus 2 secant of x is going to be replaced by u. So our formula now becomes what? So we have the integral of 3 plus secant of x tangent. That part does not change. All that is within the power of 4 is now replaced by u, so you get u4. And now the dx is du over 6 plus 2 secant tangent. So now it's time to simplify. So I don't have exactly what I have at the denominator and the numerator are not exactly the same, but if I factor by 2 down there, so I can see that they are just multiple of each other. So I get 3 plus secant tangent u4 du. And now if you factor by 2, I'm just going to do a big integral here. So you factor by 2, you're going to get 3 plus secant tangent. And now, yes, you feel it. It feels good. This term and this term, they cancel perfectly. There's an over 2 that I can kick outside. He has 1/2. So now I get the simpler integral of u4. And now this is a basic power rule. The indefinite integral of u4 is u5 plus 5. So you get 1/2. Sorry, u5 over 5. So you get u5 over 5 plus c. And now if you simplify, 2 times 5 is 10. U is replaced by its original function, which is 6x plus 2 secant of x over 10 to the power 5 here plus c. That's my final answer. All right, that's a lot of example already. So for the first chunk of integration by substitution, that's it. That's all. Bye-bye. Just joke. I was not going to finish this video so quickly. The next few examples are actually going to use a trick. And actually here you could use the trick or not. I don't really give a shit. Okay, as long as you are doing it. If I'm asking you to do these integrals where the substitution is linear, so it's like almost simple, almost basic, sorry. Indefinite integral, but inside that basic function, there's a linear equation, and there's actually a trick you can use just to shortcut sometime. But worst case scenario, if you don't remember the trick, the substitution will work. So I'll start with an example that will kind of stimulate our imagination in order to get that trick going. Suppose we want to compute the integral of cos of minus 2x plus 1. So this is obviously not a basic integral initially, so I'm going to use the inside of the cosine function, and I'm going to call it u. So you get u is minus 2x plus 1, so the inside here is going to be u, and then you compute the derivative. So here du over dx is minus 2. If you isolate dx, you're going to get du over minus 2 is dx. So I have a formula for dx, freshly computed. So here we go. So this integral will become the integral of cos of u, and then dx is replaced by du over minus 2. Of course, the over minus 2 can go up front as 1 over minus 2. I'm going to leave it like that for now. So the integral of cos of u du, the integral of cos is sine. So you get 1 over minus 2, 1 over minus 2 sine of u plus c, where u is minus 2x plus 1 plus c. And here I'm going to really write it in a special way to see what's the trick here. So if I had only the integral of cos to integrate, I know it would be just sine plus c. But now I have cos of minus 2x plus 1, and I get sine of minus 2x plus 1 over minus 2 plus c, of course, at the end. So the trick here, the important thing to notice is that if you know your basic formulas and you know the integral of cos is sine, and now the next thing to notice is that the inside is a simple linear function, you can actually jump right away and write that the integral of cos of minus 2x plus 1 is sine of minus 2x plus 1 over the slope, or the inner derivative, so over minus 2 plus c. And I can actually summarize this as a theorem. Suppose we have an m different than 0 and b real numbers. If big F is a primitive for small f, then big F of mx plus b over m is a primitive for small f of mx plus b. And we just applied that idea with our previous example. The small function would be cosine, the m would be minus 2, the b would be plus 1, and the integral of cosine of minus 2x plus 1 is big F, which is sine of minus 2x plus 1 over minus 2. And the proof is very direct. So if you want to verify that if big function, big F, is a primitive of another function, you need to differentiate that function. So here we go. Let's do this in purple. Okay, let's differentiate with respect to x. Big F of mx plus b over m. So I'm going to do this by chain rule. So derivative of big F of some shit, you're going to get f prime of that shit times the inside derivative times the derivative of the linear function mx plus b. The over m is just a coefficient, so you can just leave it outside. And of course, the derivative of mx plus b, it's a linear function, you're just going to get m. So you get big F prime of mx plus b times m over m. And then, oh yeah, the m canceled perfectly because big F is a primitive for small f. Big F prime will be small f, so you're going to get f of m, so small f of mx plus b. So it works perfectly. Okay, so, but remember that trick only works if the inside is a linear function. If it's not a linear function, you cannot use that trick, okay, because other rules will be involved. So we can now summarize this with the next remark. So the integral of small f of mx plus b is the indefinite integral, of small f mx plus b is big F of mx plus b over m. So you just need to divide by the slope only if the inside is a linear function. Okay, so make sure you don't use that trick. Okay, if the inside function is not linear, it's going to really blow up in your face. When you know that trick, though, it's really, really powerful. For example, if you want to integrate 3 sine of 5x plus 3, so we know the integral of sine is minus cosine, but now the inside is a linear function. Well, il n'y en a pas de problème. Okay, so since the integral of sine is minus cosine, you're going to get, minus cosine, you're going to get 3 minus cos of 5x plus 3 over, you just need to divide by the slope here, so over 5 plus c, and that's it, that's all. Okay, if you know the trick, you can apply the trick, but don't worry if you don't. So here, just to make sure that it's clear, okay, the inside function 5x plus 3 is linear, so you can also do it using a u substitution. Okay, and do it the long way. But here, I'm just using the trick. Next example, I have e to the power of minus 0.1x. So the exponent of the exponential function is linear. So here we go. Okay, so you're going to get 2e to the power minus 0.1x. So because the integral of ex is ex, the integral of e to the power minus 0.1x is going to be e to the power minus 0.1x again, but now you just need to divide by the slope. This only works because the substitution. If you were to use a substitution, it would be the linear function minus 0.1x plus c. If you want to simplify, dividing by 0.1 is multiplying by 10. It's negative counterpart here, so you're going that to, you can also write that this is equal to minus 20 e to the minus 0.1x plus c. Again, you can do it the long way too, but if you know the trick, use the trick. Same thing for secant. If I want to integrate 5 secant of 3x, because I know that the integral of secant is the ln of secant plus tangent, but now I have secant of a linear function. So here, if I was going to use a substitution, and it would be 3x, but now I'm just going to use the fact that I know the trick. So I'm going to write 5, the coefficient stays, ln of secant. So be careful, now the inside is 3x everywhere, so secant plus tangent. No, it's 3x, and you need to divide by 3 because the slope is 3 plus c. Again, you can also do it by using a substitution, but I use the trick for those examples. All right, now that's it. That's all. Bye-bye,